So hello everyone, thank you for coming to this talk about GraphQL and caching. My name is Martin, I'm here together with Benoit, or should we say Bod?
Hi. Both.
So I'm going to use Bod and Benoit interchangeably during this presentation, but it's the same person. We both work at Apollo. Apollo is a company that is doing tools to help companies work with GraphQL APIs, and we are working on Apollo Kotlin, which is a client for Kotlin, and obviously Android, but also iOS, like all the targets that Kotlin supports. Before we dive into the caching details, I want to make a small refresher about GraphQL. If you're not aware about GraphQL, GraphQL is an open source language to describe and run your APIs. Well, that's a very formal definition. I like to think of it, or I think a best way to understand GraphQL is to compare it with REST. In a REST world, you typically have multiple endpoints. And if you're a company like Facebook, for an example, you have endpoints for your users, you have endpoints for your comments, for your feed, all this kind of stuff. And it's working really well. You have one endpoint, it gives you data from your backend, you display this data on your website, and everyone is happy. But the things start to be a bit more complicated when you start adding more apps to your service. So if you're Facebook, maybe you have a tablet, maybe you have mobile phones, maybe you have smartwatches here. And every time you add a new product or a new app, you have to go back to your backend developers and ask them to create new routes and new endpoints for you. And this adds friction in the process because, well, you create a Jira ticket, you wait for the next sprint, and you wait for QA. Well, you know the drill. So Facebook in 2014 was in front of this problem, and they were thinking, what if instead of thinking in terms of route, we think in terms of graph? And instead of exposing a lot of different endpoints, we expose just one endpoint with the full graph. So this is an example of a graph. This is obviously not the Facebook graph because it would be way bigger, and also because it's not public. But this is how it looks like. And the nice thing is GraphQL defines a completely typed language. So like Kotlin, you have lists, you have scalars, you have nullability, you have interfaces, objects, all that kind of fun stuff. But this is not what we're here to talk about today. And really, the focus and what I want to say here is that the main thing you need to understand for this presentation is that with GraphQL, the client is in control of what's requested. The client asks the field and the data that it needs, and it will get only that back.
So how does it work in practice? Well, here we have the syntax for a query in GraphQL. You can see that it looks a bit like JSON. And quite simply, you list the fields you're interested in. And if one of the fields is of a complex type, you list the subfields and so on recursively. It's a kind of a tree structure. And here's the format of the response. So here, no surprise. Just like in REST, it's JSON. But one thing to notice here is that you have a kind of a symmetry here, or like a mirror image, because indeed you will get only the fields that you request. So if I were to add one field, it would be there. But if not, it's not there. And so that's this is like a specificity to GraphQL. That is good for network performance and also for debugging and all that. But that has some consequence on how to do caching. And indeed, we're here to talk about caching. So let's look at what you would typically do to implement caching in a mobile app. Usually, you would have some kind of database. Often it would be an SQL database, but sometimes something more, something a bit different, like Realm, for instance. And you would map your entities to tables and your fields to the columns in these tables. And usually a bunch of foreign keys to link all that together. You usually do that manually. This mapping you would do manually, either at the beginning of your project or whenever an API changes. You can get help from tools like Room or like code generation with SQL Delight, for instance. But the thing is that that way of doing it doesn't really work well with GraphQL, because as we said before, in GraphQL, in the payloads you receive, you don't have all the fields. You only have the fields that you requested. That's what we mean here by partial entities. So in this example, we have two queries. They both return a user, but with different fields. So how would you do this mapping? So here we have the user table. How do you represent the fact that you may not have some fields? So one thing you could do is mark all the columns as nullable. So if you don't have one field, it's null. But of course, that's not very good, because now what if one value is actually null? Null is a perfectly valid value in JSON and in GraphQL. Not sure. So okay, another thing you could try is, instead of mapping your entities to tables, you could map your queries to tables. So now you have two tables for this. And okay, so you only have the fields you care about for each query. But that's also not ideal, because now you have the data in two different places potentially. So that's not good for the space on your device. Like, you may waste space, you have data duplication. And also that's not good for caching, because if you look at one table instead of the other, you could have a cache miss, even if you do have the data. Another thing you could try is just store the JSON payloads directly, so cache the HTTP response. That could be good, because I mean, that's an easy way to do it. So it's simple to implement, simple to reason about. If you do this with OKHTTP, it basically comes for free. But again, that's not really ideal. Here we have an example with two payloads that represent actually the same object with the same ID 42. And again, you would store this in two different places, because you would probably use the query as the key for that. So again, they're stored in two different places. That's not good for your space, and that's not good for caching. So okay, we listed a bunch of things that don't really work well with GraphQL. So now let's look at what does work with GraphQL.
The solution we found that works well is to do cache normalization. So again, that's a very formal word to say we transform the response into a list of records. And the record, you can really think of it as a list of properties. It's a map keyed by a string. This is something, as a Kotlin developer, like, I can see your hair starting to pull, because we don't like this. We don't like this in API, because it's untyped, more or less. Like, it's really unstructured. But bear with us for a moment, and we will tell you that it's not as bad as it looks. And really what we want to do here is turn a nested JSON into a flat list of records, where each record is very flat. So in that example, I take the data object and I move it to a record. And what I'm going to do is take the user object, flatten it, and store a cache reference instead of storing the full object. So I have a cache reference here that links to my second record, which is at key number 42, and that contains all the data for that user. The nice thing with this is when we want to add fields, it's as easy as merging two maps. So we don't have to do deep copies or do things like this, or modify multiple tables in a SQL-like database. We just add a property, and because everything is really flat, it's really easy to do. This all works because everything has an ID, but it could also work that's a valid question. What if there's no ID? So if we take still the same example, but remove the ID, we at Apollo, we are going to use the JSON path as an ID. So for these two objects, we have the data and then nested user. So we will have data and data.user. And this is actually working really well. This is working fine until you have the same object at two different paths. And this is a very valid example. If I'm going back to the social network example, you might have comments in your social network. So someone like Bod or Benoit might do comments, and comments have a user attached to it. So you can end up with this situation where you have the same user available both at the root of your response and also nested inside another object. And when you flatten this, you normalize this, you have your list of records. Well, that's really bad because, again, duplication. And as you guessed right now, we don't like duplication. We like everything normalized. So really, that's the first takeaway of this presentation. If you are going to use a normalized cache, please ask your backend team to use unique IDs and to add unique IDs to each entity in your graph. And also, if you're a client developer, make sure that you include the ID inside each and every query.
All right, so now you have a cache with a bunch of records. They all have IDs, so it's all normalized correctly. But as Martin said before, these records, they're like maps of a string to any. It's not typed. So of course, that's not what you want to manipulate in your code. What you really want is something more like what we see on the right here, which is structured and strongly typed like data classes. The good news is that a library is able to use the schema of GraphQL, all the type information that's in there. It's all type safe. And so you can go do the reverse operation, basically take these records and use them to recreate some data classes like this. And yeah, that's one thing that GraphQL is good at, is doing powerful tooling around it, thanks to the schema, for instance. And speaking about tooling, let's talk a bit about Apollo Kotlin. So it's an open source library. First and foremost, it's a GraphQL client. It's on GitHub. It's on version 3.6 currently. So it's been around for a few years already. You may have known it as Apollo Android, but the name has changed because it's no longer really specific to Android. And the way it works is that it generates code. So it will take your queries written in the GraphQL language, and with the help of the schema, it will generate a bunch of models that you can use in your code. That's the data classes I showed before. And some parsers that are able to instantiate these models and fill them with the data coming from the JSON payloads. So doing code generation is good because it's all type safe again. There's nothing like any runtime introspection or anything like that. And another thing that Apollo Kotlin comes with is an implementation of the normalized cache that works exactly as Martin described. Let's just have a look at how to use it with a bit of code. So here you define an in-memory cache, and you simply set it on your Apollo client. Apollo client is the main entry point of the library, if you will. And that's basically it. From now on, all your queries will go through this cache. There's also, of course, a persistent version of that. It's called SQL normalized cache because under the hood, it actually uses SQLite. But one thing to note is that it's really a simple usage of SQLite. So there's no mapping like we showed before between your entities and tables. It's just one big table. It's a key value thing. You can also use both at the same time by chaining them like this. And if you do so, it will be good for performance because you will go first to the in-memory one, which is very fast, and then fall back to the persistent one, and then fall back to the network, of course, if you have a cache miss at this point. So caching, okay, now you have a cache that works. You can do other stuff once you have that. For instance.
Watchers. So watchers are the cool stuff. So we've seen so far that, what is GraphQL? We've seen the traditional problems, I mean, the problems with traditional approaches, so traditional problems, I guess. We've seen how using a normalized cache can actually solve this problem, and Benoit just showed you how this is still type-safe, even if we don't store it in a type-safe way. And once you have all of this, once you have created your normalized cache, once you use it in your app, you can use it as a single source of truth for your UI. So every time you change something in your data, you can get notification about what changed. How do you change something in your data? Well, that's using a mutation. If you're not familiar with GraphQL, mutations are to GraphQL what a post is to REST, so it's really the same thing. There's a slight difference here. It's that the mutation, also returns the data. So here you see I'm going to update the status of someone. This someone with user ID 42. And in response, I'm going to get back the status, so a confirmation that the status was updated. And if I were to write a simple app, because in the end, this is what we want to do, right? We want to write apps. An app that displays the status of this user, I'm going to start by showing a loading screen, because we all do that at start, and call this watch function. So this watch function, the first thing it's going to do is it's going to go to the network and get the initial value of the data. Maybe this was this morning and Benoit was working from home, so the initial status is working from home. Then the watcher is going to suspend because it uses coroutine. It's really nice, like it doesn't take any CPU, it doesn't block a thread, anything. It's just sitting there, like in the state machine, waiting for something to happen in the cache. Now, Benoit is going to click that small button, or maybe I do it, or maybe you do it, and update his status. So it's going to start a new screen with a text field where you can change the status. Let's say we are now at droidcon London 22. So we send that mutation to the network, and in response, we get the new data. So we get the data from the network, and it updates the cache. And as soon as it updates the cache, the watcher in the background is going to update the UI so that if you press back, you have instantly the new value of your status. And if you look closely, like this is, at this point, I think we are all aware about this. Like this is the very definition of a unidirectional data flow. So this slide is completely stolen from the Android developers' website. It's from, I think, the Compose documentation. But anyway, it's all the concept that you have state and you have UI, and UI should be a function of your state. And with a normalized cache, something that I like a lot is that I think of my normalized cache as a graph of data, and my UI is a graph of views. And when you think about it, well, the two are quite similar. So it makes sense that you can map from one to the other. And with something like Apollo normalized cache, you can even do some stuff like changing to offline support, supporting offline mode with just one line. So that was it, a few mandatory conclusions. The first one is that GraphQL allows for a lot of tooling that makes everything type-safe, and we love type safety. Second one is that if you're using the normalized cache, you can make your app work offline with just one line. So this is pretty cool. And last conclusion, at this point, I think you got the message, is that you should always define your IDs both in your schema and in your queries.
To go a bit further, speaking of IDs, the way you would declare them, the way you would define what fields are IDs in version 2 was programmatic. With version 3 now it's declarative, so it's a lot easier. So check it out if you're interested in this. Another thing is that we did a bunch of improvements on the cache side related to data age and also to pagination. So we listed here two tickets if you want to have a look at that. But also we've actually published an incubating library to already test all that. So yeah, same thing. Don't hesitate to try it and give us feedback. And lastly, something that like caching is not only for the clients, it's also a concern on the backend. So here we just listed two keywords that you can Google. Cache control to control your headers on the backend, and automated persisted queries, which is a technique to avoid sending payloads all the time from the the client to the backend. And just for inspiration, so there's this project by John O'Reilly, who is here, called Confetti. It's a very good example of an app that uses Apollo GraphQL and the normalized cache, but also Kotlin multi-platform and other things. If you haven't seen John's presentation from yesterday, you can watch it probably soon. Yeah, so check it out if you're interested. It's open source also, so have a look. And that's it. Thank you.